So 3 case studies. The first one that I'll share very briefly is the Arkstorm Project. This was a partnership with the US Geological Survey. We have been very fortunate to meet Dr. Lucy Jones from the Multi-Hazards Group at USGS. Several years ago, we were involved in the great Southern California shakeout. I don't know if you remember, for those of you who are here in California, this was a fantastic effort that really brought private and public sector together to really reimagine new awareness for preparedness. And our center was very involved in that effort. We were on the steering committee as one of the organizations that really worked a lot with the public in terms of translating messaging, positioning the shakeout as a brand, and creating a specific earthquake preparedness work. A few years later, the same team at USGS was charged to model with a number of scientists and emergency preparedness personnel across the country. They looked at modeling a new scientific scenario, this time focusing on the scenario of a catastrophic winter storm, one similar to catastrophic storm that occurred in the 1860s here in California. That was really very destructive, produced a lot of floods, and of course at the time the state was not very well populated, so it was not a storm that created tremendous loss of life. But back, fast forward several decades later, a winter storm of that proportion, which is plausible, would have tremendous economic impact in our state. So the challenge that our students and our faculty had around Arkstorm was really twofold. One was the role of creating communication messaging about this potential scenario of this winter storm and how people would have an awareness about a catastrophic storm, what would be consequences in terms of flooding, and what would be measures of mitigation to take on. And the second side of the work that was done was really situating our center and our community of designers as conveners and translators for a group of very diverse scientists and emergency planners and policymakers. And so I will not show you all the communication that was produced, and I urge you, there's a 10-minute film attached to this work that I urge you to look at on our website in the interest of time. But I wanted to run this quick film, and this was produced as the design team really was in charge of facilitating a 200-person summit up in Sacramento that brought everyone that had participated in this scientific scenario. The scenario was being unveiled to some policymakers in California, and there was a real goal to bring the community together to discuss the results and the findings of the scenario and really develop consensus for future policy for the state. So it was a really strategic effort, right? How do we create tools of conversation over a 3-day summit with these important decision makers and get them to think about actionable steps forward after science and findings have been unveiled. So it was a very strategic design effort attached to Arkstorm that I thought would be important too, and you can see the number of agencies that were in the room. That would be important to point out to as one area where design, again, functions as a very strategic translator and convener in this space. So this was shown as everybody was getting ready to start the two-day conversation, and there were several designers, faculty from Art Center, and graduates in the rooms leading and facilitating conversation over 2 days. And again, the right image shows you the report for Arkstorm. And prior to this, it was really students from Art Center College of Design that named the scenario. The scenario was being developed, but it took a whole team of communicators from Art Center to name the storm, give it its brand, give it its image, and then that work continued. So this is work that happened over 2 years. Scientists, emergency planners, policymakers, and our center teams working very closely together and collaborating to, again, bring consensus and bring some accessible information around this scenario. And you can see some sketches and visualizations as the summit was going on of questions. So public awareness materials and this convening, and then the summit itself in Sacramento. The second project, of course, is one that was a great joy to be part of, and that was our collaboration with Jerry here and the Aquarium staff a couple of years ago now. And as it happens often in these projects, we work very closely with partners to co-create the challenge, what we would call the design brief, that our students and our faculty are going to take forward and investigate over a whole academic term, which can be 14 weeks, and sometimes much longer if it's a graduate level program, or if it's a multi-pronged project like Arkstorm. These projects get embedded in our curriculum and occur over 2 or 3 semesters at a time. In this case, the challenge that Jerry brought to the team was really around sea level rise and the impact climate change is having in sea level rise. And the goal of the project was to imagine communications and potential exhibitions here that the aquarium could take forward, or other aquariums could take forward, that really would be accessible to families and young children, and get them informed about the impact of climate change in our sea level rise, and really get focused on this idea of resilience and how to dream up a better future, and a future where we are informed and where everyone's actions is having a consequence. So the team of students here, you have them with a couple of our faculty, Frido and Hydra and Mumperdrum, who's part of the series. You can recognize her in the back if you were here a few weeks ago. Faculty from the product design department who were very involved in this project. There were graphic designers in the team. And working very closely with the aquarium and other scientists that came and lectured. They really immersed themselves around the data and the challenge, and came up with about 5 or 6 projects from a 14-week research process. And I thought I would show you just a couple. This was a wonderful idea for a very fun exhibition, interactive exhibition for young kids that was called Rising Seas. And it had 3-dimensional components, it had 2-dimensional components in terms of posters and engaging information that would really get the kids to experience different games that at the same time as they were playing would really teach them facts and figures and bring a sense of awareness about sea level rise and the consequences in a scale that a young child could comprehend and make sense of. this is an exhibition that has to happen still, Jerry. But there was a game of hopscotch with a lot of fun facts. There were takeaways that were imagined. And it was, I think, one of the strongest concepts that came out, even a climbing wall with a sea level. So there were really very, very interesting directions that were explored for this work. And again, I'm going through this very briefly, and you can read about it more on our website. A second project, same team of faculty, another team of students in the class that I wanted to point out to you, is one that has actually been published since, and that I think was extremely thoughtful and showed a very different approach, definitely for an older audience of kids, the Sustainable Aquaculture Project. And this team did a lot of, and what's wonderful about these collaborations with science and with designers in the environment of a studio at our center is that although we have a brief and we have some constraints and goals about what we want to produce and where to find research data and experts to voice perspectives, we really, because we are an educational institution, and we're working with young designers that are learning still their craft, we want to be quite exploratory in the way the process of the collaboration works. So faculty guide these projects, but it's really the teams that do the research that come up with original concepts for potential solutions or potential directions that can be taken forward. So in any kind of partnership or project that we may do, there may be 5 or 6 very different approaches around the same topic, the same challenge. But every designer in these projects have a lot of authorship and the opportunity to really be very creative. So this team was very interested in ecosystems of our fisheries, and again, the impact of climate change in a growing global population in terms of our fisheries. And they ended up designing an interactive exhibition that is centered around the idea of a pinball game. And they constructed this pinball game, which was beautifully crafted with wood and plexiglass. And you have the pinball. And basically the ball represents nutrients. And the goal of the game is to get the ball to go into the side of the pinball that really is geared towards most of the nutrients and the fisheries. And they did really really very sophisticated, I think, it came up with a very sophisticated concept to translate quite multi-layers of information into something that had a very straightforward act. So just a beautiful sustainable aquaculture pinball game. And then lastly, a very recent project, and you are the first ones in this room to actually see one of the communication outcomes of this project. It hasn't been released to the public yet, and we're very, very excited. This is a project, again, with Dr. Lucy Jones and the team at the U.S. Geological Survey Multi-Hazards Division, who are working with scientists around the country on, this time, modeling a scenario for a tsunami that would hit our harbor here in Los Angeles. The scientific scenario will be ready and unveiled this spring. And as part of that unveiling and that work, we've been joining forces for the last year to think about communication and identity for the scenario, communications around it, and a series of public awareness messaging around tsunami preparedness, attached to the scenario, but also going forward beyond the scenario. So the first role a team of communication designers from our graphics and illustration department at our center had was to work very closely with scientists to think about a name for this campaign that would be released next year. And after a lot of research and back and forth, this is the logo, this is the name, The Next Wave. And there was a lot of exploration, not only, again, trying to understand a lot of what we know to this day about tsunamis, how they manifest, what kinds of communications are and signage is out there, and a lot of exploration to develop the brand for The Next Wave. A lot of exploration around possible applications of this campaign in a number of outlets that people would like to relate to. Here, obviously, they did a lot of work with the surfing community to understand how they could be involved in a public awareness campaign about tsunami preparedness here in Southern California. A lot of work around posters and communication to translate it. And this is, and then a very interesting small brochure with very important scientific preparedness information about how to act, but in a very, really getting the messaging to really be simplified and digested in a very simple way that people can access and remember. So this identity and some of these communication pieces are going to be implemented not only here in California, but in a couple more states with our USGS partners in the fall. And a second stage of this project was to develop, and here you have there's a lot of assets here and a lot of images, so just to show you a lot of the exploration and the wealth of ideas that students and these teams develop before one gets ultimately chosen with a partner. So there were a lot of applications with social media that probably are not going to go forward because they would be more difficult to implement. But thinking about Facebook and Twitter and different ways of getting information out there. So this is part of the whole communication strategy that gets brainstormed and thought through games and a number of some crazier ideas than others translating this idea. But something we are very proud of and very excited with our partners about is a short public service announcement that was just produced and finalized that will be widely disseminated, and it's so exciting that we will actually be doing 2 more within this series. And it's called The First Tsunami, and it's obviously a play of words. It takes a lot of, and these are some images of the research the motion graphics team that has produced this public service announcement did to think about, again, translating very complex information in a memorable, catchy way that the audience is going to remember. So you can see some fashion references, some pop references, pop culture references. All of that gets then developed into an original storyboard for this public service piece that I'll show you now at the end of the presentation. But before I do that, I wanted to show you a behind the scenes a quick couple of minute video with Dr. Lucy Jones and others, and our faculty and our students and the artists involved in this piece, and how they develop this motion graphic piece before you see it. So run that now.
And action.
We are trying to help have safer in tsunamis. As a scientist, we're studying what the tsunamis do, trying to really understand what the impact is, but that doesn't tell you what to do to be safe.
And California Emergency Management Agency has the charge to help people be safe during tsunamis. So we know what to do. We know what we'd like someone to learn.
But neither of us can give it. And so we turn to the Art Center for Design for help figuring out how to get these messages that are really critical to people's lives out to people to understand. This type of collaboration, one, is essential to doing our job, but it's also just incredibly more effective. For several years now, we've done various activities with Art Center, and every time we blow away the other scientists and emergency managers. So how did we come up with that?
We didn't come up with it, we let communicators come up with it. And that's not the end of it. In addition to Art Center, USGS, CalEMA, our partners in local government also help us with the message. So they're the ones who are going to be helping us deliver the message to the public. So it's sort of a cradle to grave approach to really getting the message out. It'll make people safer during this tsunami.
And we discovered that when we try to do it by ourselves, we're really good at what we're good at, but the rest of it tends to fall down. So we've created lots of pieces of science, lots of emergency management essays, better than before. And so it's imperative for us to do our jobs to do these partnerships.
I wanted to show you this behind the scenes piece just before we roll out the PSA, and then we'll be up to Dan to follow. Because I think Lucy says a couple of things in this piece, right? And one of the joys of working with her is that she really advocates for this kind of partnership that we have for the last 7 years. As a scientist, she's the first one to recognize that this issue of translation and of getting to the public with emotional and memorable images that they can relate to and act upon. This is here again where the magic of partnership and the collaboration happens. It's also very important for us to say that our center, when we're doing this work, we really rely on these partnerships in terms of the expertise, the data, the rigor of the scientific message, and always want to protect that in a way that might be interpreting and translating that, but being very careful that the data that gets used is scientific and data that we can stand by and be proud of. So that's the other side of it. So let's watch tsunami.
I don't usually make tsunamis, but when I do, I prefer to use earthquakes. Last name Nami, first name Sue. People don't understand tsunamis, and I'm here to fix that. If you feel shaking, that's an earthquake and a tsunami warning sign. Get away from the water. The first wave could be the smallest. It's unbecoming, but destruction's my middle name. Hence, the next wave could be bigger. Nothing compares to how tsunami actually feels. You might see water sucked out, like a really fast, really low tide. You might hear a loud sound, like a train in the ocean. Recognize these signs. A tsunami could be coming right now. You need to get to higher ground, uphill or inland. You don't want to get wet. Like me. Sounds like the next wave has already arrived. See, I'm already making a difference.
Thank you.
So a little bit about my background. So I went to Art Center and I ended up having this one professor who was this old Chinese fellow, and you'd ask him about how to do an ad about Nike or an ad about something, and he would tell you about the Roman Empire, and he'd tell you about Atlantis as if it were all true. Well, it may be true, I don't know. And then he'd tell you about like yesterday's stock market, and he'd kind of ramble on for 20 minutes, but you didn't really know what he was saying, but at the end, you knew exactly what you were supposed to do. He never talked about shoes, but somehow you figured out what to do. And so I was going to do a little independent study with him, and there's this place in Highland Park. Have you ever heard of Galco's? It's a grocery store. They sell 500 kinds of soda, and they're all in bottles. And that's sort of the essence of this place, is the bottle, because when you make soda in a bottle, they use sugar cane instead of corn syrup, and it's in a bottle, so it tastes better than a can. And so I started to do what I was at Art Center for graphic design, and I was going to do what a normal graphic designer does. They make logos and posters and that type of thing, and I started to try to make a logo, and I really, really struggled. And eventually he said, Dan, you're just too practical. You need to stop being so practical because it keeps you in a box. You need to go out and play. And you're so practical that you'll take these impractical things that you play with and make them practical. And I thought about that, and I didn't exactly know what to do because I was almost about ready to be done at Art Center. You're supposed to get a portfolio piece, and if you just go play, then you might not get one, and what are you going to do? But I took his advice. And so I started to play around with the essence of this store, this bottle. So I started to, kind of make little, this is interesting, kind of seeing my screen up there because it's not on here. Playing around with bottles like this, and then I thought, maybe you could put them on top of the building in different ways. And then I was always interested in the way in which you blow on a bottle and it makes music or it makes sound. And so I would drive around with bottles on top of my car, and it didn't work at the beginning, and I had my friend push it up and down. That didn't work either, but eventually I got the right angle and the right distance, and it made a beautiful noise. It would go, woo. And so I thought, wouldn't it be cool if they had a taco truck stand and drove around like that, and just like an ice cream truck. And then my friend has perfect pitch. And she went around all these different bottles and found me a scale, music scale. And I don't know anything about music. I don't know what that scale is. But this is sort of the story of my life, is that I usually don't know anything about most things that I try to do. I try to come up with a really compelling idea, and I'm really good at asking questions. So and networking and trying to find people who do know the answer to things. And so eventually, I made this little drawing, and I had no idea how to actually do this, but I figured this must be the setup to make a pipe organ out of soda pop bottles. And I had no idea what that was, but I figured it must exist somewhere, and turns out that it's a solenoid. And someone said, oh, you need a solenoid. It took like 3 months for me to find out what that thing was. And so eventually, for my graduation show, at that time at Art Center, if you were a graphic design student, everything was very flat on the wall. And I had all these crazy sculptural types of things. And these are things I never would have came up with had I gone through my normal process. And so I thought, wow, this is a lot of fun. And at that moment, Art Center had opened up a little communication with Caltech. and Caltech allowed Art Center students to be with, go through this internship program. And I went to, I found there's a guy who was an artist, a fine artist, that was working with scientists on ways of visualizing lots of data. And I showed him this, and he said, great, you're going to do the same thing here, except you're going to come up with new ways of visualizing data. And it's a whole other story. I got to swim like an otter for half an hour a day, trying to come up with ways in which transparency and iridescence would help you communicate more information in visualizations. And I thought, man, this is awesome. You know, what better thing to do than this? And so I've been looking for an opportunity to work at a research center. And I ended up at the Jet Propulsion Lab. And for those of you guys who have never been there, don't know much about it, there's 5,000 people there. It's a big place. It's right next to the Rose Bowl. And we do anything from have satellites that go around the Earth that look at the oceans and the land and the sky, to telescopes that look at stars and galaxies far, far away, to landing on Mars. The recent rover that's on Mars was built and managed and conceived of there, as well as many of the spacecraft that have gone to other planets. So it's a big place, does lots of different things. And this is going. One thing that I found is that some people are better at communicating than others, and some scientists are good and some are not. But many times, the best ones are the ones who really communicate well. And this is a Feynman diagram. Richard Feynman won the Nobel Prize. He went to, he was at Caltech. And I remember reading a book of his, and he said that if he couldn't communicate to a freshman class what he was thinking about, then he didn't know what he was talking about well enough. And I felt, man, that's really important, because when I first got to JPL, people, I'm an art student, I don't know what these guys are talking about, and I felt like, oh, these are all just really smart people. And then they would all, we'd be in a conference room, and I'd be the last one left with someone else, and I'd say, what are they talking about? I have no idea, And I realized that a lot of times they didn't know what each other was talking about, but they were too afraid to ask the question. But I was not afraid to ask the question. And so that really is true, that you need to be able to, if you really understand what you're talking about, you need to be able to communicate to people. And what's fascinating about these Feynman diagrams is that he came up with this simple, if you're in this world, he came up with these really interesting little diagrams that were very simple for these people to understand and communicate amongst each other. But years before Feynman had gotten to this point, there was another person, and I'm awful at names, so I can't remember who it is, but it's in my laptop, which I can't get into, that had came up with really similar ideas, except that his way of doing it was really complicated. And if you go look this person up on Wikipedia, in his article, it says that this person figured these things out many years ago, but his ideas were so complicated that he has been all but forgotten. Oh man, and so I show this little presentation where I highlight that and I say, you don't want to be one of these people, do you? Every scientist, no scientist wants to be all but forgotten. So I started out with graphic design, but I've kind of branched out into lots of different things. This was one of the first things I did when I got there that deals with finding planets around other stars. And to me, that's just a mind-blowing thing that we've been finding planets around other stars. And this kind of gives you a sense of scale. Because they talk about all these giant numbers, and I'm not very good with numbers. In high school, I had a 2.98 GPA. I never took SATs. I wasn't passionate about very much when I was in high school. But eventually, once I started to get into this, I realized that my passion is to be able to give people a moment of awe about the universe that we live in. And so that's what I strive to do. And so if you have a grain of sand, and that represents a galaxy, we live in the Milky Way galaxy. You need 6 rooms to show all the galaxies that we know about. That's a lot, right? So each grain of sand has hundreds of billions of stars inside of it. And I'll do this installation where I have a lot of sand, and then I'll have a magnifying glass. And I have, underneath of that magnifying glass, I have a single grain of sand. And what's cool about being at JPL is I can go to someone and say, can you drill a hole into a grain of sand for me? And they can, it's amazing. So if this were our galaxy, this little hole right there is where we found hundreds, like 800 planets so far around other stars. We found a few beyond this hole since I've had this done, but still, you know, a majority of them are within that little tiny area. So most of those are large planets because we don't have the technology to see smaller planets. So we found lots of planets, and we're going to find thousands more over the next few years within that little tiny area of our galaxy, let alone the rest of our galaxy, let alone the other 6 roomfuls of sand. And if you want to like that, look at the magnifying glass.
How do you drill a hole in a grain of sand?
You actually do it with a carbide drill bit. They actually had smaller carbide drill bits, but I didn't want to have an electron microscope to see it. So I showed that. This also deals with finding planets around other stars, and one of the first times I got to do it was here, and but it has changed a bit since then. Figure out where I'm at. Basically the idea of finding planets is stars are really big and bright, and they're so big and bright that you can't see the really small dim thing that you're looking for, which is a planet. And so somehow you have to block out a really bright light to see a dim light. And so in this, I have a big honking projector, super bright, and it projects this kind of yellow, red pixely thing, and sort of feels like a sun. And so when you walk up, that's all you see, and you have no idea what you're looking at. But someone invariably has to do shadow puppets. And so they get out there and they start playing, and then they realize that there's something more there. And then they kind of get more people, and they block out more of it so that they can see more of the story. And we're trying to find evidence of water, so I have imagery of water in there. So this has been a lot of fun to take around. Funny story, when I did it here at the aquarium, some lady said, why don't you just stand in front of, why don't you just turn that other light off so you can see the movie? Well, that wasn't the point. So, sometimes it doesn't always get across. Recently I've worked a lot with a mission that's going to Jupiter. And Jupiter, this mission is called Juno. And it launched last year, and on October 9th, it's actually going to fly right past the Earth and get slingshotted out to Jupiter. And one of the kind of funny stories about this one is that before it launched, we were asked if we could brainstorm some sort of idea, something that could go on the spacecraft. And I thought, oh, it's an amazing idea, amazing opportunity. And got some people together, and we couldn't come up with anything. Then we just got, well, nothing. I wanted to do something meaningful, something that was not just, because NASA will do a lot of trivial stuff, and I wanted to mean something. My friend, after the brainstorming thing, wrote me up and he said, Dan, in Italy, Galileo, the scientist from long ago, who discovered the moons of Jupiter, his bones are on display. And I said, wow, that's bizarre. And turns out that one place has some fingers, and another place has some vertebrae, and some some private collectors have other parts apparently. He said, yeah, what if we could get a little fleck of one of his bones and put it on the spacecraft? And wow, that's amazing. And but how do you talk about something like that? Because that's it's kind of morbid, and so we started to talk about it, and turns out that the spacecraft orbits around Jupiter 33 times, and then it's going to fall into the planet because we don't want it to contaminate something else. And so he said, well, what if he discovered the moons of Jupiter? He would become a moon of Jupiter for a whole year. So that sounds really romantic, right? And then he would become one with the planet. And wow, that's really amazing. And the University of Padua, which is where he taught, has his vertebrae, and they were like, here, we've figured out how to find this little fleck and give it to you. And wow, that's great. But we have to get all of our things in order. And NASA actually approved it if the Italian Space Agency would approve it. We thought this is a no-brainer. But the guy who ran the space agency, he had just become the director, and he wouldn't let us do it. Which is a bummer. And I thought, well, maybe it was like the Catholic Church or something, but actually, the Pope has a scientific advisor, and they're an astronomer. And I actually called his former advisor, somehow I got his number, and he was like, you should do it anyway. I thought maybe that would be cool, but I wasn't close enough to the spacecraft to do that. So. But the Europeans are going to hopefully send something to Jupiter, and maybe that guy won't be there, and maybe it'll actually still happen. But in the meantime, I had to come up with something else. And so this is an installation. We'll turn it up just a little bit here, like halfway. Yeah, okay. And so Jupiter is a giant storm. There's no place to walk around on Jupiter. And so I made this room. It's a big room. I made a big cloud in there. So when you walk in, you see this cloud, and you hear thunder and lightning. Turns out there's huge thunder and lightning storms on Jupiter. But you don't see any lightning. But people love to take out their cell phones at any time. Doesn't matter what it is. And this is the longer version. But underneath this cloud, I have a whole bunch of infrared lights. And infrared you can't see with your eyes, most of it, but a lot of cell phones pick up infrared light. And so the only way you can see the lightning is through your cell phone. So just as with science, they have all these detectors that you need their detector to see cosmic rays. This is the only way to see it. And it's awesome when there's a big subwoofer. And we're trying to get a sense of the interior structure of the planet. So projecting it, this is really cool to see in real life. See these little lines going through. And then again, the name of the mission is called Juno, Juno. And every once in a while, you can see the name pop up.
Where is that?
Well, it's in my closet right now. So the hope is that we will, I'll get a show to New York in the summer. I'll have a bit of a story about all that at the very end. Just so you guys see behind the scenes here. It's not fog juice that we use. It's actually it's tap water, and this is an ultrasonic mister, and it has these little pieces of ceramic vibrate so fast that they vaporize water and makes it into this gorgeous mist. But that mist will stay within that container unless you blow it around. So we have these. Oh, look at that. anyone remembers what a record is, the speed of a record, 33 1/3. So the idea is that we're wanting to work with a bunch of musicians to write music, to beam it to the spacecraft, and then beam it back encoded with data from Jupiter. And then every time that it orbits the planet, it would send a signal, a code to your app, or our app, and it would unlock one track. And it orbits every 11 days. So every 11 days you would get music that would hopefully be like a world release. And so we're hoping something like that will someday happen. But it's hard because it doesn't get there until 2016, and people, think that's a long time, a long time away. So it's hard to get people like they're like 2016. Our company may not even be around in 2016. Let's see, just to kind of go through a couple other things. I do a bunch of other stuff at JPL. Sometimes I work on covers for their proposals, and it's all about storytelling with their cover. Because all the time, they always just put a spacecraft next to the planet it's going to. And you're not buying that, NASA's not buying that spacecraft. They are, but they're buying what it's going to do and what it means. And so I always try to figure out what does this mission mean? And this is one of my favorite ones. I was fortunate because we didn't have much time, and I was in a meeting and I didn't really understand what they were doing, but some guy at the very end, he said, what we're trying to do is trying to, we're listening to the trees of the Earth, and the trees are the lungs of the Earth. And I thought, wow, that's really fascinating. So a tree kind of looks like a lung, and it would be we'd be working with the Brazilians, and that's what that bird is there. We didn't win this one, but it's still a beautiful cover. This is another one. Let's see if this start how fast this will load. Another one about the composition of the leaves. And this was I worked with this was the first collaboration I had with the Juno team, and the main scientist said that Jupiter is like this giant code, and if we decode Jupiter, then we can understand the history of the solar system. And wow, that's really beautiful. And then I realized that every single person says that about comets, or about Venus, or about Mars, or whatever. They all have the same story. But, and then this is just another version of the same sort of. A little bit more fun. But I also work a lot with the people who brainstorm new missions. And this is an area that I want to be much more involved in, and something I find fascinating. We developed this room called Left Field, so the ideas come out of left field. And it's a fun, if you go to JPL, it's very Brad. Everything was built there in the 60s, and it's, designed by engineers who don't think about, humans being in this space. And so made this brainstorming room where there's floor-to-ceiling whiteboards and a bunch of stuff there to help you quickly prototype ideas. And it's been a lot of fun to kind of work with them, because they're not accustomed to working this way. And so now having, I have a number of people working with me. One is was a product designer, and so she's really good at making stuff. And another guy who's a special effects person, an architect working with me, as well as someone who's into advertising. And so it's been fun to be part of this and being part of the brainstorming process of what are they going to do in the future. And there's some opportunity to be able to have an influence on a piece of hardware that goes to space. That would be really, really cool. So lastly, I'm just going to show a little, this happens to be like spaghetti noodles there for a thruster. I'm just going to show this. I got to know, I was doing portraits of various researchers, and one guy who studies snowpack in the mountains and trying to figure out how much water is in the snowpack. And kind of crazy fellow, he called me up in the summer and he said, Dan, can you meet me in Yosemite tomorrow at noon? And I said, what? Because if you know anything about bureaucracy like JPL, it's like hard to get permission to travel and be there tomorrow, and I don't even know where I'm supposed to go. And he didn't really tell me. He said, yeah, you'll just meet me on this hill. And I'm like, dude, the whole place is hills. Where am I going to find you? And so I went up there, and what they were doing is they're using laser scanners to look at the topography, and then they fly over with laser scanners to get a little bit lower resolution but higher larger area. And then they go back in the winter and they do the same sort of stuff, and then they can figure out how much snow is there, and then they can figure out how much water is in that snow, and then they have models to figure out how much of that water ends up in San Francisco for you to drink. And that's really important for a lot of reasons. And this is my first chance doing a little documentary, and was kind of scared through the whole process, but I think it turned out pretty well. There'll be a date in here. The only text that's on there, the date is incorrect, so if any of you are fact checking, it says first cut, so I haven't gone through to change that, but this might be a good way to end, and you can make sure the volume is.
There's an enormous void in our quantitative knowledge of the mountain snowpack, and pressure is being put on us increasingly to be able to know that mountain snowpack because it is our primary resource for water.
So when you fly over the mountains, you can see snow down there and no snow over there, but you have no idea how deep the snow is or how fast it's melting. The Airborne Snow Observatory gives you the information on every patch of snow as to how deep it is and how fast it's melting. And that's key information for water managers, for ranchers, for farmers, for boaters. The list goes on and on.
The Airborne Snow Observatory is two instruments put together that look at the surface that tell us how deep snow is and how much sunlight that snow absorbs. And those two combined are what control how fast water comes out of the mountains and how much of that water comes out of the mountains from snow.
Cool. What happened there? Not quite where it's at. It jumped.
What control how fast water comes out of the mountains and how much of that water comes out of the mountains from snow.
Oh, that's really good. Isn't that great? Having great fun. Yeah. Well, it was beautiful. Very poignant. And you got the idea that we're trying to understand the water and the snowpack. So, sorry about that. I don't know what we're going to do right now, but I wonder if I think I don't have Ethernet up here, so things kind of slow.
browsing nowadays.
Yeah. Here, how about this? I'll pause it right through it. And try it one time in the middle. It's a beautiful sunset. I haven't seen it in a while.
What control how fast water comes out of the mountains and how much of that water comes out of the mountains from snow.
We need a mission like the Airborne Snow Observatory because we very poorly know how much snow there is in the world's mountains and how fast that melts and comes out of those rivers. The Airborne Snow Observatory is providing a wall-to-wall complete characterization regularly through the snow melt season. So this is the future of water management in snow melt fed regions.
Well, we made it through.
So, thank you. I'm a ballet dancer. Okay. And I'm here to talk about science, which is kind of interesting. You know, like ballet, science. Ballet dancing is something that most people don't have a lot of interest in. A lot of people have never seen a ballet before. Hey, how do you see it? I've been a ballet dancer since I was 11 years old, and well, that's a pretty presumptuous to say I was a ballet dancer at 11 years old. But I've been taking ballet since I was 11 years old, and I danced professionally for a few years, as Jerry mentioned, and I've had the Long Beach Ballet now here for a little over 32 years. And the reason that I have been asked to come and talk here is because I got asked to do a project for the Aquarium to use ballet to try to influence people about the environment and about the ocean. There's probably some of you who've never been to a live ballet performance. Most people think that ballet is something that they would be really interested in because you don't really understand it. It uses classical music, which maybe you don't like. You just don't get it. You don't see men dancing around in tights. But ballet is actually I missed this slide. I was going to say that, like, there's one way that ballet dancing can support scientists, and this would be it. That's not me, by the way. I didn't know that. Okay, so ballet is the ultimate way to tell a story, and I'll tell you why. When you want to tell somebody something really important, you do a face-to-face, right? Why is that? Because body language. Because body language is more powerful than the verbal speech. Much more powerful. You don't say to somebody really, well, you don't engage your fiancée over the phone. You want her to see you. You want her to see the expression of your face. Saying to somebody, you really mean a lot to me, is meaningless compared to a look in your face that really says that whole thing, okay? Body language is the most important. It takes you right back to our primitive way of communicating. Verbal communication is very complex in the brain. It goes through a whole verbal center in your brain that's very, very analytical, and you lose a lot. You have to translate. You have to translate that into feelings and emotions. With ballet, you don't. Ballet is telling a story with no words. You don't have to think, you don't have to be lectured to, you don't have to be told anything, you just watch and you take it in. So ballet really has an amazing potential to tell a story. The best ballets throughout the centuries were the ones that told stories. You've all heard Swan Lake, you've all heard The Nutcracker, you've all heard Sleeping Beauty, Romeo and Juliet. People who like ballet, they love those. Anybody really likes them if they really ever get the first go. Some people don't like classical music, but classical music is actually, everybody likes it, everybody actually loves it. I've never met anybody who said they don't like classical music, but who didn't love Raiders of the Lost Ark, Superman, Back to the Future, and all of those have classical music scores. And it's what makes them amazing, what makes them great, right? So this combination of great music like that and the body telling a story, that is what ballet is about. So when we got asked to come here and meet with Jerry about a meeting to do a ballet called Dance of the Chorals. That's how it first came out. And we were supposed to do well, it was suggested to us that, because I have a ballet school and I have a lot of little kids, that we do something where we bring in kids and they dress up like corals and jellyfish and stuff like that, and sort of educate people somehow, and I didn't know how that would work, to educate them about the ocean. But I suggested that we do something a little bit more elaborate than that. Well, I got a story from Jerry and his wife, Margaret, and they sent me because I said, well, send me something. This was way back over a year ago. Send me something. So they sent me a story, and it was full of facts and figures and statistics and warnings and scientific data and times and dates. And I looked at that and go, oh, how can I turn that into a ballet? And so I wrote back an email, and I said to Jerry, dear Jerry, my challenge is to create a production wherein the presence of human ballet dancers gracefully enhances the subliminal impulses that we want the audience to develop, rather than interfering with it. Not going to be easy. Classical ballet, in harmony with classical music, does have the potential to stir subconscious emotions, but the storyline of our project must give the dancers that opportunity amidst a sea of conscious data, predictions, and conclusions. The finished product could be accepted as a masterpiece of artistic scientific unity, or it could lie flat as a botched attempt at singing. Well, neither of us was that, and I am anxious to meet this trial head on. So we started out by trying to figure out how we're going to educate people without being able to tell them any facts and figures. That was a huge challenge. So we decided to start in the beginning. I actually took a suggestion from the beginning of Jerry's scenario that he sent me, which said, why don't you start at the beginning of the world? Ooh, cool, good idea. So what we did, and unfortunately there's supposed to be music playing now, but this point of PowerPoint is not like my rendition of how this worked. So I was playing in the background some of the music we actually used in the production, which was an important part of this, of course, the beautiful music. But we went through a series of trials and errors of coming up with how to tell the story. But we started in the beginning of the universe, and we went through, and once we came up with that first scenario, we'll start at the beginning, then we set out to try to find the music. For me, when I choreograph ballet, I get a rough idea, I find music that's amazing. Music that anybody will love. You don't have to think about it. It's not analytical. It's not, it's just something that's beautiful music. Something that just moves you, like, in a major symphonic score for a movie. And so I find a little bit of music, and then I think, ooh, that's good. Now I can develop the story a little bit more. And then I find a little bit more music, and then I find a little bit more story, and then pretty soon I have music and story complete. Once the music and story is complete, then we start choreographing on the dancers. What we did with this, once we had the beginning of the universe started out, then we went to where plants and animals were on the earth. And the earth was in perfect harmony, perfect balance. This music's really pretty, by the way. Unfortunately, when I hit the space bar, it's going to stop even though it's not supposed to. This is some of the music we use in the ballet. It's one of the most beautiful pieces of music. Anyway, so then we went to go forward and we showed the emergence of man. And then man becomes very ambitious and creative and populous. And he starts to build lots of buildings, and create a lot of amazing things, and he starts factories. And pretty soon man is really churning, and he is churning stuff out. And in his naivete, making all of these deals with people, they're getting rich, they're spending money. Naively, man goes so far that he starts to pollute. Doesn't really realize for a while the harm that it's causing on the planet. It's not like man is bad, it's just that man got very excited about all the amazing things that we were able to do. Creating factories, creating cars, making ships and all this different stuff. So we get to a point where, wow, something has to happen. Or if it keeps going in that direction, it's really, really bad. Okay? Well, in the ballet, we call that off, we call that up there. There's 40 dancers in this ballet, by the way. And when we did it in the aquarium, in the big great hall, we had a big stage, we had a huge projection screen in the back, and on the projection screen it was a multimedia. We were projecting images that showed pretty much like scenery, like that. The pictures I showed you so far were all on the images. It's actually a video. And the next scene is we go down and we visit the fish. We go down in the undersea and we get to see oh, this is a very low-res fish. These are very ancient fish. That's why it's low-res. These scenes are portrayed by dancers. And kind of like in Little Mermaid, Little Mermaid, where she's got her collection of junk, like, oh, look, the dingle hopper, Well, the fish are enticed by this interesting stuff coming down there. They're like, wow, look at this stuff, look at this trash, it's fun. And they play with it for a while. The music's very loud and very lively. But then pretty soon you see in the background this stuff falling down. Anyway, the trash gets to be so much that it sort of engulfs them and overpowers them and they start dying. The next scene is we're on the beach, on the land again, and the people, the main man, his wife, and there's a couple other guys, and like that. They're on the beach, and it's at night, and they're having fun, they're at a picnic, and they're shooting golf balls into the ocean, and throwing the trash in the ocean, and the bottles done. And some dead fish wash up on the shore, and his wife is very shocked by this, and she points it out, but some other guys, and each guy comes up and just gives him one, and he says, don't worry about it, just bring it back. But he's very conflicted, the man is very, very conflicted. And he goes to a party in his house and they have a big party and he gets really drunk because he's so conflicted about what's going on. He's making all this money, doing all this great stuff, but then his wife's telling him, you realize you're killing animals, fish and stuff like that. And he's like, don't talk to me about it. And so he gets drunk and he goes into a stupor and he has a dream. And in his dream, this is the background behind the dream, which is a really cool image. But he has a dream, and in his dream, he is sort of attacked by fish all around him. And it's very, very powerful, very strong music, and he's about to be completely overwhelmed by these fish. And then a beautiful fish comes and stops him and saves him and rescues him. And this fish gives him a gift of a big, beautiful seashell as a gift from the fish to man. And this is the turning point. This is where he can't believe that this fish is doing this for him. And he begs forgiveness from the fish, and the fish forgives him. Fish is my daughter. So he wakes up, and he is resolved to change things. He decides, he tells his wife, I'm going to change. We can do without some of our fur coats, but we have to be responsible to the earth. Now, of course, this is all, I've been giving you this all in words, right? There's no words here. There was nothing written in the program. Nothing was told to anybody about the story. There was no story written in the program that we gave out. So he decides to change things, and the last scene, the finale, is the humans and the fish all come together. The earth is happy, everybody's good, joyous occasion, and that's basically what the finale is about. The thing is that I came away, at the end of that first performance, having created this with my creative team, including Johnny, my choreographer, getting it myself, understanding what we had done, and we did our best to portray the story the best we could. But I didn't know if anybody else got it. You never know with something new. This had ever been done before. When we tried to sell this thing at the aquarium, basically we got a bunch of reaction like Dan did. We told him at dinner right before. He said, like, ballet at the aquarium? What? That would be like saying, oh, we're going to do Swan Lake at the beach. people wouldn't buy tickets for that, you know? So we didn't, it was very difficult to sell tickets for this thing, because people really didn't, you know, they couldn't picture how could you do a ballet at the aquarium, why would you do a ballet at the aquarium, it doesn't make any sense. So I'm standing there, and we had a pretty good audience, and I didn't know people got it, and I was very excited when a gentleman walked up to me. This gentleman walked up to me, Dr. Alan Friedman, director of the New York Hall of Science for 22 years, one of the top scientists in America, walked up to me and said, "Oh my God, that was amazing." I said, "Well, thank you, thank you." And we talked for that late that evening, and he wrote an article for a magazine called Curator Magazine, which is a national publication for museums. And he sent it to them, and they were so excited that they made it the cover story, and we were the cover of the magazine in January 2012. And we can read this together. Because this is a culmination, basically, of what I'm saying here. This is what we did. We were able to do something nobody had ever done before. We took ballet and told the story. Listen to this. A ballet may be an extreme example of communicating science in a science-rich cultural organization, because there are literally no words in this communication. There's music, video, costumes, props, and above all motion, but no words. A year earlier, I would have pleaded for words, at least a full explanation in the program of the science which informed the ballet, preferably with a scene-by-scene explanation of the history of the scientific understanding which I believe is represented in each scene. But that must not be how successful ballet works, because somehow, without any words and only a single paragraph of explanation in the program, this performance manages to discuss the evolution of life in the seas, the very different kinds of life which later evolved on land, how the two realms came into conflict, and the sensibility which might allow that conflict to be resolved. In the heart of Guardians is a dream sequence in which a man somehow finds himself in the presence of a lovely sea creature danced by a 16-year-old ballerina who offers him a seashell. The dream marks a central turning point of the story, as the land creatures eventually come to appreciate the value of the diversity of sea creatures, accept responsibility for the impact of the land creatures' actions, and undertake new roles as guardians. Learning through a dream is about as remote from traditional science pedagogy as I can imagine. But perhaps it is a missing piece we rather desperately need to communicate the really important things about science. Not through deep psychological analysis of dreams, but through made-up dreams as one of the artist's tools, so different and so complementary to the tools we are comfortable with as science educators. Not that it would hurt to have a scene-by-scene or to invite the public to debate the meaning of the ballet, but those are tools that are just not essential to the power of ballet to communicate. So, there's the museum cover, and I rest my case right there.